All right, picking up for segment two, where we left off, we were talking about cations and how they form. Cations are metals. So cations tend to lose their electrons. And if we look down here at where it says 3s1 for the electron configuration of sodium, we know that it has one valence electron. Well, it wants to get to that 8 that we just talked about with the octet rule. So is it going to gain 7 or lose 1? Atoms tend to do the easiest thing possible. So they're inherently lazy in nature. So if they're always going to pick the smallest number. So gain 7 or lose 1, one's the smaller number. When you lose 1, you actually became a 1 plus charge because you have 1 less negative charge. So it's always I tell them think of the opposite. So it's Na plus 1. Calcium, for example, as we just have an example, it's in group 2A, so it has 2 valence electrons. We're going to say gain 6 or lose 2. Pick the smaller number, so it's going to lose 2. And when it loses 2, it becomes a 2 plus ion. So just looking at all cations are metals. They tend to have few valence electrons, 1, 2, or 3, which means they will lose them and always form these positive ions, which we call a cation. Don't worry about the name right now. We come back to that in chapter 9. Anions are going to be the opposite. Anions are always going to be nonmetals. They tend to gain their electrons for the opposite reason. I guess it wouldn't be the same. Sulfur, if we were to look on the periodic table, ends up having 6 valence electrons. It's the S and the P's. So we look at it's in group 6A, so it has 6 valence electrons. Gain 2 to get to 8 or lose 6. Again, pick the smaller number. So it gains 2. When you gain 2, you become a 2 minus charge. So when we look at sulfur and the anion that it becomes, it's going to be S2 minus. Again, if we look at an example of phosphorus, phosphorus has 5 valence electrons because it's in group 5A. So the fact that it's going to gain 3 or lose 5, it's going to pick the smaller number and gain 3, which then means it becomes a 3 minus. When we look at the end, the noble gases that we talked about end up having 8 because everything wants to be like them because they're stable. They don't tend to gain or lose electrons. They don't tend to bond. And that's basically the octet rule and how cations and anions fit into them. But the bonding itself, the reason they stick together isn't because one gives an electron and one gains electrons, because of their opposite charges, and opposite charges attract. So when we make an ionic bond and we write a formula, it's the simplest whole number ratio of the atoms that will make that come together. Both electrons are trying to either lose or gain electrons to achieve noble gas configuration. So we call all ionic compounds salts. So when you hear salts, not always sodium chloride, which is what you put on your food, but there are bath salts. There are salts you put into, there's sea salt, there's salt you put into your hot tub. All of them are salts, which means they're just a metal bonded with a nonmetal. Cation and an anion transferring electrons to become ionic compounds.